I'm recording. You all know, well, except Joseph, pretty much how my classes look. I want to share this, but I want to go to here. Every one of my class D2L pages look like this. You all found it because you found the Zoom link. I put out that first message about a week before classes even started, which is last Tuesday. And wanted to make sure you folks did a bunch of stuff on your own to get up and to get running. Just on this screen right here, you know where to click for Zoom, office hours if you have any interest. Being a small group, hopefully you start to rely on each other. You know, in breakout rooms, people start to come out of their shells and so forth. But today we're going to talk about this more classes. It's right out of the textbook. You can see the topics for each of the weeks for the 14 weeks. I didn't do a chapter 9 review. We're going to talk about it today, so it's going to actually be tied in with this. I was going to do a separate one, but you all just had chapter 9 not that long ago. But it's really important in this class. Here are old recordings, and these are going to be shorter. These are going to be longer. This used to be meeting twice a week. The push is to meet once a week. Okay. And so you'll have stuff outside of class that I'm going to say, hey, I want you folks to get together, maybe in a group of 3 or group of what. You have permission to use my breakout, my Zoom room. So if Adam and Nat, you say, hey, let's get together and chit chat about something, you can sign into Zoom and meet at a certain time and use that just for the 2 of you, or the 3 of you, or the 6 of you. You all want to agree on a time. But there's an emphasis of you doing more out of the class and not me saying, okay, I want you going into breakout rooms and you need to sit here. And as much as they're great, you can kind of do that on your own as well. So then I'm doing more teaching and less jumping into rooms saying, what you doing, what you doing, what you doing. So, all right. You know, if you have any questions, most of you know me and will say, can you repeat that? Stop, slow down. Otherwise, I get excited and keep going. Everything from the nav bar, I had that on that discussion video. Today we are doing GADIS 14. So here are all the files from there in one big zip folder. But we're going to be starting with some static members of the functions, just the members. We need to knock some lingo off for classes because we're going to start to do a bunch of stuff with classes. Some of you had 230, which you do a lot of stuff with classes, but this is the C++ version of what we're doing. I'm trying to come up with a way to start this, and I'm going to switch over to my camera. Stop sharing this. And are you all good with an IDE? That is VS Code or Bloodshed. VS Code offers more functionality than Bloodshed, but for me, Bloodshed is really easy to load up and go versus VS Code. Use whichever one you want. As long as I get the right files, I'm good to go. Okay, I'm learning to use VS Code because students do, but I've used Bloodshed for 23 years, so it's one that I'm more familiar with. You just had a month and a half off. I'm going to change my view to speaker and me, and it's black. That's not what I want. I want this. There it is. My document camera. All right, let's do this. Make sure we knock some rust off. Top 10 things. Top 10 things from CPS 161. Topic wise, give me one. Give me one. Good. C strings. These are just 10 random things, not the top 10. 10 random. We did a little talk about C strings and how they work in C as well as C++. C being the legacy code where it started from. C++, the plus plus means we're adding all kinds of stuff onto it. What else? Adam, go ahead.
Uh, Integers? Constants?
Yeah, we had our variable types, but we went a little bit more in depth. And let me throw some things out. We did some sorting. We did sorting. We're going to do a lot of sorting in this class. And we had three basic types. One was an exchange sort. One was, so that's when I swapped them side by side. One was a selection sort where I picked a value and I moved it. Does anybody remember what the third one was? I believe it was the insertion sort. It's like a hand of cards. As I pick a card up, I put one right in. Here's a big one, pointers. And that's that whole chapter 9 review. And we'll talk about it. If we need to take a break and jump back into chapter 9, we can. But we got into using the addresses and we got into the asterisk. One, we used it to declare a pointer, and one was what we called dereference. What do I mean by dereference? Dereference was something like this: ampersand num equals 100, or num pointer, I should have called this. It says go to this address and assign the value 100. Okay? Again, that's chapter 9. Go back and look at the code listings and you'll be going like, yeah, I got that. We did a bunch of stuff with files, didn't we? We updated our knowledge of working with files. And outside of these courses in college, you start to get into a world of big data. And big data has files written all over it because you need to import all that data and all that information. And we looked at some things with files that were an upgrade from what we did in 121. We finished with a little bit of recursion, and that was a function that called itself. And we're going to get back into recursion in 162 because there's a couple of sections, a couple of functions that you're going to go, I have a function that calls a function that's recursive, and oh boy, I need to be able to understand it quickly. So that's why you get a little bit of that in 161, and it comes up. Here's another big one. So what's a big one? Pointers was huge. This is another one for this course, and that was our structs. We did structures. Remember, we created a new data type, and it may have had an integer and two strings and a double, but these two become big real fast in this course. Why am I doing this? Well, what if you say, oh crap, he just said structs important, and I may have to go back on free time and take a look at some structs. After structs, we did something called an enumerated data type. That's not really a biggie, but that's one that makes the list. It was different than 121. Here was a big one. We did vectors, we did arrays, and we compared them. We compared them. This course, we're going to do arrays versus something else and how they work side by side and how that something else is a little bit like a vector, but way more powerful. Under vector, we said this guy was dynamic. Means it changed. We were able to get more size if we needed it. We could reduce and free up memory if we needed. This guy had the term static. It was a static data type. I'm going to assign 400 of them, period, and done. Can't add any more. Can only leave some blank. These things that we're going to look into are called linked lists. These are going to be similar, and they're going to have the whole dynamic idea going on. We did a little bit of work with multi-dimensional arrays. That's going to come up closer to the end of the course, how we're going to do some comparing. And one of the big things, number 10, was an algorithm writing. Now, you got it at the beginning of the course, hopefully, and you did some algorithm writing. And sometimes you uploaded files. You had to upload the algorithm. You had to upload test data. You had to upload your screenshot of your output. And we'll be doing some of that as well. But this algorithm writing is going to become important because you're not going to be able to do, come on, you're not going to be able to do some of this stuff without writing things down first. We gotta, what are we gonna do? We gotta write this out. And a lot of that is gonna come from this guy right here. I'm gonna say, draw the picture. Draw the picture. And I want to make sure the picture's drawn so that we can say, oh, this is how the algorithm works. The test data. You're drawing a picture with the test data because, hey, Nicodemus, how you doing? I see you here. I can mark you. Everybody knows I do attendance. So good, good. I'm glad you made it. Okay. So we're gonna have to be like, there's only 8 lines of code, but it took us 30 minutes to figure out how to draw those 8 lines of code and get them in the right order and all of that. All right. So big things coming out from the good old days. Not a problem. I figured you were on campus with your mask on. Either that or you're robbing a bank. I don't know, but I'm going to assume it's campus because I know the lighting that's there. So you're smiling, right? Nod your head. Yeah. Okay. Good. Good. All right. Any questions? So if you're on there and all of a sudden you're like, vectors, vectors, well, we're not going to do much with vectors, but maybe I'll look over them a little bit or some of these other things. Little review, little review. Classes. So we had a chapter in the book called Classes. The very first chapter that we're going to talk about is this chapter 14, and it's called More Classes. More classes and more classes. So if I talk about a class, and hopefully you got a good dose of this back in 121, that intro Java course. For those of you from Hack, I'm not putting you out, Joe. I'm just filling you in the gaps, okay? But I remember doing, and a good old fashioned one was we did something called rectangle, beat the heck out of rectangle. And we said that's the class name. And then underneath the class name, I did my fields. We had length and we had width. And, if I handed you the UML chart, you're going, yeah, yeah, I got it. Yeah, that's good. That's good. Let's see. What did I do with length and width? I gave them data types. Maybe make them both doubles. As I said, these are my fields. Kind of remember that. This guy right there makes them both what? Not, yeah, you said, I didn't hear you, but your lips moved. That makes them both privates. Okay. If I remember, we had private, public. Private can only be used in the class. Public could actually be used in our main or our demo type of program. Then we had a third one that we only touched on a little bit, really little. If you had 230, you're familiar with, it's called protected. So I have my fields or variables as they're called. And then I started with, let's see, my methods that went in here. I had the gets, get length, get width. I had the sets, set length, set width. These guys were my accessor methods. These two were my mutator methods. Get length, brought in an integer. Set length. All right, I got that backwards. Set width, brought in an integer, and was a void. Get length, returned. I should call these doubles, shouldn't I? See, I'm so excited. I'm going so fast. But it's just a quick review of what was going on. I had my gets and my sets. And then I may have had one that says get area. And a whole bunch of other worker bee methods. Excuse me, functions. I forgot them in C++. And then the very last method that I would have put in here would have been the ever popular toString. Why did I have a toString? The toString displayed the object. Remember, if I just tried to print R1, so say I instantiated an object, R1. Oh boy, instantiated C8, oh geez, instantiated, that's close enough, the object. I created a variable. We called it instantiate the object, right? Say it's called R1. If I would display R1, it's not giving me anything. If I create a toString and display R1, then it's going to give me everything that was inside of that method. So we're starting to get an idea here of coming back to this ever popular UML chart, that if I handed this to you, you'd say, well, that class is easy to write. You're just telling me what to do, and I have simple lines of code to put in there. Then I'd have a demo program to instantiate an object and data. What's one thing that's missing that I don't have in here? C word. How about constructors? I'm missing some constructors. When I instantiate an object, it calls the constructor. There's a couple of different constructors. What if I had this area? If I had this area, or if I had this area, I have a bunch of different constructors going on. They have the same name, different signatures. Different signatures. This guy is what's called overloaded. Overloaded. We saw a little bit of that as well. But when we get into classes, we can overload methods. This is a default. This has one side. This has two sides kind of deal. Okay, lots and lots of noise, blah, blah, blah. Nobody's asking questions. I need to slow down because I get too excited. But we got the idea of what's going on. A little bit? Yeah. All right. I don't have place to put my paperwork. Were there any questions on the syllabus? Were there any questions on D2L? I don't know what that is. Got that. There I am. Any questions on D2L?
I have a question.
Sure.
Are we gonna have the code listing assignments for this class like we did for the?
No.
Okay.
And the reason is they get huge. Some of the programs that we see are just so big that you're going to find you're going to do a bunch of cutting and pasting. CPS 230, you do a lot of cutting and pasting because there's just large blocks of codes. But For this class, no, we don't have any. All right. One thing about this class is you need 2 textbooks. All right. The NIOF book, that's one we start with next Monday. And bear with me a second. I did put this out. I put this out on D2L. It's a layout of everything that's going on. Okay, you looked over Gaddis 13 on your own. Today we're doing Gaddis 14.1 to 14.5. Next week is the NIOF book. And then I'm going to give you a group project, probably, well, I don't know yet. I'm not going to say. I'll give you more information on that, but that's like an out of class thing. Same with tests. The tests are going to be, I'm going to give you a day, like I did before. You sign in, da da da. I'm being forced to make you use side cameras. I will give you more information when that comes. But you can see we jump around. The NIOF book is a little more scientific, but it does a better of jobs of, well, we learned about stacks. Let's play with stacks. It builds on a little more and gives us a better understanding. I wish I had a book that was just one book that we could stick with. The Gaddis book you already have. And for Java, so really you end up only using 3 books for 4 courses, which is a good thing. And this NIOF book is pretty cheap because they haven't come out with a new version in quite a few years. Okay, so you have this on the news on D2L, so you can see by topic what we're doing. And again, sometimes we're going to be in the Gaddis book, NIOF book, sometimes both. Okay. If I go back to D2L and I go to week number 1, I can't see week number 1. Come on, show all news. This is my screen. Week number 1, there it is. I gave you that. And we got in this, and I asked you to do some stuff from chapter 13. And I didn't get any emails or any questions or anything like that. So I'm going to guess that you're okay. Were you able to get this running? Rectangle.h, which is called a header file. Rectangle.cpp, which is an implementation file, and a demo program. Were you able to get this stuff up and running? Whether it was VS Code or Bloodshed. In Bloodshed, you have to create a project. Is anybody using anything other than VS Code? Okay, then I would try to become more of an expert on VS Code so that I'm with you and I'm demonstrating and so forth. So you had a week, no due dates per se for grades, but this is what you were working on. All right, so now we're up to looking at some stuff today, and I'm going to jump to my textbook and fill in the dots. Chapter 14. Stop sharing. And I hope you all have a book or at least something online. I go to that camera, that's me. I want to go back to chapter 14. No, where am I? I don't want speaker. I got that. Audio, I want. No, I don't. Oh, why the heck am I changing audio? Can you still hear me? Yes, okay. Sorry about that. Ta-da! There we go. More about classes. And a bunch of you know from 161, I do like to use the textbook. So we're going to run through and do a bunch of stuff with this. I mean, I always have my notes going on here. So that's what I follow. But yeah, I think we're going to be pretty good here. Okay, 14.1. We start out with a section, and you've seen this word You've seen this word a lot. Public static void main args. How many times did you type that in intro Java class? A lot. So we have that. Can you switch the audio back? Because it's, yeah. Speaker. How is this one? Is this audio better? No? How about this one? Is this audio better? No. Let me try that one. No, that's that. Let me try this one. How's this one? Talk to me. Is this is this one better?
I think it's the same.
What's that?
I cannot hear you clearly.
Can you hear this one? Can you hear me now?
They all sound like the same one.
They all sound really bad. Well, I have 4 microphones. That one's Realtek. Let me. Number 1, 2, number 3, number 4,
think 2 was the best.
Yeah.
number 2. 2?
Yeah, 2's good.
Okay. Sorry about that. So anyhow, we've seen this word static quite a bit. I used to have like a nice plug-in microphone and then it just stopped working on me. So I don't know whatever happened there. So we're going to take a look at what this static is. And if I take a look, I instantiate 2 objects of the rectangle class. You all should know that box 1 has its own length and box 1 has its own width. And when I talk about box 1, the length is 10 and the width is 5. So these are separate variables, separate memory locations than what you see here. Box 2's width is over here in memory. Box 1's width is over here in memory. They're totally different. When I work with box 1, I work with its memory. When I work with box 2, I work with its memory. Well, what if, and so there it is, kind of idea. But what if I wanted to say, I'd like to have a variable that works with both of these together. And that variable is called a static variable or a static member. So I can create something that no matter if I'm using box 1 or box 2, I can work with it. And again, the code listings are great. Just because I don't assign them doesn't mean don't do them. Okay, so I'm going to take a look at first things is we just have this thing 3 trees and it's just not a very good example. So let's see what's going on here. I instantiate an object oak. Okay, now when I come over to where it's instantiated, my class is tree. Inside of this tree class, this header file, okay, I have a static variable that I add 1 to it. When I instantiate my next object, elm, I come over, again, I'm landing in the default constructor. What's the work that's to be done when that's called? I add 1 to object count. It's a static, so now this guy holds the value 2. When I do pine, now adds 1 more, and we see a result of getting 3 out. So there may be a time with your classes where you are building, and you're going to see some examples with a budget where you keep adding to that overall budget every time you go into different objects. Okay, so this is a static variable. A static variable. Nice. I'm jiggy with that. Here's another example, and the book builds on this budget.h, and I've given you these files. So budget.h, I have corporate budget. This is what I was just mentioning on the last page. Okay, and inside of here, if I go to the demo, I come in and I'm going to have a loop for my 4 divisions. By the way, hopefully when you did that project from 13, you got back into thinking C++ style and knocked some rust off, so you're up and ready to go. Luckily, we didn't have the whole summer as a break. We only had 1 month. Yeah, 1 month. But getting back to the syntax for C++. So I'm going to go through here 4 times. And every time I come in, again, what's going on? Thank God for documentation. Array of budget objects. There's going to be 4 objects of class budget. The array name is divisions. Every time I come in, I'm working with this. Going to add to budget. And every time I come into adding to budget, excuse me, I'm going to add an amount to corporate budget. So this guy is good in all of my objects, all 4 of them. It gets the same value. It's not unique like division budget would be. Okay, yeah. Traditionally, you would define your static at the end in your class. Okay, this one we only have a header file, the .h. We don't have the spec file, the specification file, but we'll get into that. Like I said, if you're using Bloodshed, you have to actually create a project and put all the files in. In VS Code, we're good. We can just put them all together. Yeah, inside of my demo, I call the header file. Okay, so again, I'm still old school. I like using the textbook. Then I can go to right where I want and so forth. I'm printing it out. So that's not so bad. That's the first part of this section. Second part comes into what's called a static member function. And here's what I liken it to the math class. The math class in Java, we could say math.square root, and we never instantiated an object. We're just going right to the class and using one of its methods. We didn't have to. So I want to be able to create a way to set up a function that's static, that as long as the class is included, I can go grab those and use them as I want without instantiating an object. This should look pretty familiar. The only thing is, there's the word static that's out front. All right? I declare them in a class, and I use them outside a class. Cool. Let's see what we got. I define this header file. I got all of this stuff in here that I need when I'm creating the header file. I have a static variable or static member variable inside of here. And I also have a static method. Now, this header file, which is what we're going to start doing, the header file is only going to include function names. Now, if I take a function and I put the work inside, it's called inline. But for example, here, I'm just going to put this function name. Now, when I get to the CPP file, that's where it gets defined. When I come to the specification file, I define it. So now we have 3 different files, the header, the spec file, and the demo program that we're working with. I think now would be a good time to pause and have you load up. Let me see if I come back over to here. This example of a static member function. So I want you to load up 14.3 budget.h, budget.cpp, and get those up and running. The header file, the spec file, and the program that uses this. I don't have any background music to put on, or I would. And with our fingers crossed, it'll work. And you may possibly have questions coming out of this. And again, they can be called anytime, anywhere. Ba, 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 ba. So I got that, and I'm going to have that. So we're building a project now. How we doing? Are we getting it to work? Somebody want to share their screen? I can pause the recording. All right, so I'm going to move on. Section 14.2. Again, more stuff with classes. This time we have something called a friend of a class. All right, we're going to start budget. Here we go. We got version 3. I'm on page 825 of the book. I don't know if you have text or if you have the online e-text or what. I don't know. But we have budget, and you notice line number 3. Include auxil.h. Include. So we're going to look at the big picture. Include.auxil, and oh boy, here we go. I'm saying that auxiliary office is a friend function. Oh boy, I come in here. What's this? I'm passing a double and I'm passing a what? What is that? That's an address, right? Budget ampersand. That's an address. Remember I said chapter 9, da 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 da. That's coming back. So here I now have the contents of auxil.l. I have auxil.cpp and a bunch of stuff going on. So we have this thing, it's called a friend function. And some of you, most of you that have had me, I come back and I say, okay, so it looks like there was a class, but now maybe another class, but a friend is a function or class, is not a member of the class, but has access to the private members of a class. We thought we were locked down with if I make something private that nobody else can use it. CPS 230, you're going to find a lot of other ways to use it. But for now, we have a friend that's going to be able to use my private, I shouldn't say it like that. It's going to be able to use my private variable. I don't want to say use my private members, my private variables in that class. Okay, so when I come over to 14.4, I have oh, what's this do? What does line 16 do? What's budget? Budget's a class, right? Budget's a class. All right. Inside of that budget, I say main office, and I'm passing a variable in. Where's main office? Well, whoops. Here we go. Here is my budget class that we've been working with. This is my header file. I have some inline functions, and I have a friend function from over at auxiliary office. Over at auxiliary office, there is a function called add budget. Oh, okay. Class auxiliary office, add budget. So if I come over here, I'm going to be able to use the add budget. Here it is in my header file, and then it's going to be typed up in my .cpp file. So when I get ready to use it, here we go. We won't do much with friends. I think the important thing is that I can share, that I can give a friend access to my private variables. But to spend a lot of time on the code and so forth, for as little as we'd use it, we don't have to know. We can come back and find it in the textbook kind of thing. Thumbs up. Okay. 14.3. This concept has been talked about. We're going to re-talk about it again. And shooby-dooby-dooby-doo. What does that do? Line number 19. Box 2 gets the value of box 1. Box 1 has length and a width. Box 2 has length and a width. What does this line do?
It changes the contents of box 1 to box 2.
No. Nope. What does this actually do? This isn't the contents. When it comes to content, we have to go deep. This isn't deep. Yes, very good, Nicodemus. This is saying box 2 now gets the address of box 1. So box 1, blah, 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 blah. Give me the and we've kind of seen this before. Box 1 goes to here, has a length and a width. Box 2 goes to some other location, a length and a width. So we have the values. What was it? Box 1 was 10 and 10. Box 2 was 20 and 20. And now when I see the line, box 2 gets the value of box 1, it now says, these don't change. This changes. So in my output, you'll see that box 2 now has the value of 10 and 10. They both point to the same address. These 20s are lost. They're still sitting in memory. They're still sitting in memory, but we don't know where they are anymore. How do we take care of this? Well, we have a fix. The first thing is called a copy constructor. And the copy constructor is going to say, hey, I need a constructor that brings in a constructor and then assigns the values. A copy constructor is a special constructor to call whatever new objects create. And we need an example. We need an example. I don't think this is really, really good code this time, but let me see if I can find it here. We're going to come in, and here would be a constructor. What's coming in is the address of an object of type student test scores. So this is my constructor with one parameter coming in. Okay, what's coming in is an object. So when it comes in, the name of my passed in object goes to my, this is the one that's this dot student name. Okay, it's the calling object. We copy over that, we copy over that, we copy over all this array of scores. Everything's going to get copied over. Deep copying. I can do it in a constructor. I can do it in a constructor. You said that, I know. Here it is again. Doing this copy, bringing everything over. I just want to see an example of how it's called. I don't see the example of how it's called. Should be somewhere. But anyhow, it would be the object name with a parameter coming in. What does that const do? It says, don't screw up this parameter that's coming in. And if you try to screw it up, it's going to be fixed back to itself later. Because remember, this is the address coming in. I couldn't possibly change the values in here. I want to lock that bad boy down. Okay. Cool. So that was method number one. Method number one was this guy right here, a copy constructor. The second solution is going to be something called operator overloading. And the operator that we're going to overload is the assignment operator. It's the assignment operator. So let's take a look at this. Okay, section 14.5. We're going to overload. Oh, hang on. Where am I at? This operator. Boy, I think I said it right. But we mentioned before about the this operator. We've overloaded this already, right? So we've done some of this to some extent to start. So overloading an operator. Here's the syntax. This is going to now allow me to say R1 equals R2 means copy everything over deep. All right. I come in and I don't want to screw it up. Here's the operator that I want to overload. I want to overload the equals. I'm bringing in, this is my class name. I'm bringing in a pointer and I'm calling it right because it's what's on the right side. I'm going to copy everything over inside of this. I am returning what was on the left side. So when I say R1 equals R2, it's coming in and copying everything over and then so this is sort of like a null return. I'm returning to this, which has this getting new values. I think it's this course. We not only overload the equals, we can overload any operator we want. In this case, we're overloading the equals. You need to know we can do it. Then you go and you find all of this information. What does line 64 do? It checks the address of the one on the left to make sure it's not equal to the one on the right. If it was, we don't have to do all of this. So it's a quick check. Check, Mike, check. And then this should work. Everything individually gets copied over. Remember, we overloaded it. So if it sees this, it says, wait a minute, this isn't my normal equals where I have an integer gets the value of an integer. This is an object getting the value of an object. That's an overloaded operator. How about this from Java? Num equals 6 plus 2. system.out.println hi plus mom. That plus is overloaded. This does a concatenation of two strings. Remember, we used this in our output statements. So we've seen overloaded operators already. Now we can do what we want with overloading operators so that it works more than just with integers or just with, yeah, we got good stuff going. Nice. Nice, nice, nice. All right, let me see where I'm at in my notes. 14.1, 14.3. We took care of all that. How far are we supposed to get today? 14.5. All right, let's see what's going on in 14.4. This is a good one. I like this one. I would like you to go load up feet inches. Go and load up feet inches. Now, if I go to D2L, you're going to have to go to chapter 14 zip file, and then you can download all of those code listings for chapter 14. But we're going to take a look at this feet inches. I'm going to pause to give us a couple minutes to load it up. All right, here we go. So we're in section 14.5. We're talking about overloading an operator, and I have you doing something called feet and inches. Love this program. I like this program. It's hard to love any program. But anyhow, let's see what I got in my header file. I have feet, inches, and void simplify. I've made all of these private. Public. First thing is a constructor. So what do I have inside of here? Feet and inches. And I can call simplify. Wonder what simplify does. Well, I know it's not defined in my header file because I made a note. It's defined in my specification file. Okay. Oh, I bet if my inches is 20 inches, my simplify gets called and says, no, 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 no. We're going to add one to feet and change inches to 8. Oh, that's kind of cool. It does it right away for me. So simplify is somewhere else a little bit later. All right, I come in and I have some sets and I have some gets. My mutators, my accessors. Oh, it even says that. Help you remember. I'm overloading plus and minus. Why am I overloading? Because the left and right side are both going to be objects from the feet inches class. So I want to be able to add 2 objects. I want to be able to subtract 2 objects. Okay, now this is starting to make a little more sense. That last example wasn't the greatest. Okay, I come in and I have all of my syntax and get all that straight. Here's simplify. If inches is greater than or equal to 12, we do an integer division and add that number to feet. We do modulus and add the rest to just inches. So that 20 modulus 12 would give me the remainder, which would make that 8. 8. Hopefully nobody messes around with it, but what if they type in negative inches? Then you got to deal with that clown. I like simplify. I like this program. It's kind of nice. Now, the definition of my operator is overloaded. I want to be able to take 2 operators, add them together, and store it in a third operator. I come in, my current inches, I add the right inches and assign it. My current feet, I add the right feet and assign it. I call, simplify, and I return. This guy is going to be almost the exact same, except instead of minuses or pluses, I have minuses. So if you ran this program, you typed in some test data, it comes out, it should be like, man, it's pretty cool. Like it. Getting a lot of heavy code that half an hour ago, you may have been going, of a constant, bringing in a pointer to an object, and oh boy, all kinds of stuff. The author I like. The author I like. And if you look through the rest of that section, there's all kinds of stuff that we can continue to overload. We can do relational operators. We could do all kinds of stuff. So I am done, but here's my hope that Wednesday, and again, you don't have to do this, you can do it on your own, but I strongly encourage you to build this community. Or someday this week, and maybe it'll be Wednesday, that you go, hey, everybody, Wednesday at 11, we don't have class. Maybe we should meet in the Zoom room. I just made that up, Zoom room. And take this feed inches and add that copy constructor that we talked about. Overload that equals that we talked about, because these two sort of went together. Remember, instead, so that I could do the assignment instead of passing addresses, this goes individual. And maybe I can overload this to add an inch, the plus plus, or something along those lines. Maybe I can overload a relational operator. So again, here's what normally I would sit back and say, okay, I'm putting you in rooms, you have 35 minutes. I'm just going to sit here and wait, maybe answer 1 or 2 questions. I'm giving you the option of building your own community, maybe Wednesday at 11, because my Zoom room is open. Maybe 2 or 3 of you want to meet another time. That's up to you folks. You can put it on the discussion board. You can email the group. Does anybody want to get together Wednesday at 11 and upgrade use feet inches? That's all up to you. So I'm going to stop the recording.